Good morning, everyone. This session will start. I'll give an introduction on our speaker. Our speaker is Tajudeen Akinosho, who is a current MSc student in computing at the University of South Africa, which is UNISA. He holds an honors degree in computing from UNISA and is also a BSc honors in computer science at the Federal University of Agriculture, Abeokuta, Nigeria. He holds a higher national degree in statistics from Yaba College of Technology in Lagos. His research interest includes data engineering, data science, machine learning, big data, and high performance computing, with focus on quantum computing. And today he'll be giving us a talk on introduction to data streams using River. Over to you.
So I want to briefly talk about introduction to data stream using River. I said River is one of the libraries that you can make use of, which is embedded in Python. Other libraries are there. Mostly, the ideal platform for data stream is the massive online analysis MOA, but it has also been incorporated into other areas like Python and like R. But one of those areas that you can use it on is on R. So let me quickly just give you the brief introduction to why are you using data stream? Because data streams is around us in all what we do in the gadgets you hold. You have data stream coming in regularly, and why you need to do analysis of it is because it takes little time just for you to analyze. If you don't analyze this instantly, those events may not be the same. The modeling are different. So that is why it is data stream. It comes frequently, and you have to quickly analyze it as it comes in. So take, for instance, the issue of the COVID pandemic that we witnessed 2-3 years ago. You have to analyze a series of events that take place, or else you'll not be able to carry out any modeling there. So let us quickly look at what data stream looks like. I'm going to my, can you see my screen? Okay, data stream. Data stream is unlimited. It comes in regularly. It is potentially unbounded and continuously evolve with time. Data streams are everywhere around us these days. Of our everyday life is now getting stopped with devices that are emanating from data streams. As I said, all what we have now, they always come, and you have to quickly analyze the event that takes place. The CCTV camera, your sensors, devices, every other things, you must quickly analyze it as it comes in. And for you to do that, you need special tools, not just any other tools to do that. So among those things that you find data stream coming up, you have your cell phones, the cars, the security sensors, the radio frequency identification, the earth monitoring system, and your televisions. These are some of the examples that you have that emanate data for you to stream. And then in some few years to come, our smartphone houses will be a kind of areas that we have to quickly analyze things from, or else we'll not be able to get a real event to analyze. So data streams, they are different from the batch or online learning. Your data stream is the online learning, but the batch is the normal traditional learning. So how do you get this approach? The batch learning approaches is capable of gradual learning. That one is capable of gradual learning. They are usually built models from the entire training set. You know, in machine learning, we have the training set and we have the testing set. But these are things that differentiate batch learning from the online learning. They are what computationally expensive. At least if you want to do the batch learning or offline learning, they are computationally expensive. Then the difference between the online learning training is done in small groups. As I said, they comes like just few events and you must analyze it immediately and try to make a decision over them. Each learning phase is quick and inexpensive. The event may come and it may not repeat itself again. So you have to analyze it as it comes in. We have one limited number of computational resources. This is the output of the batch learning and the online learning. So let me quickly go through some of the libraries that you have in Python for machine learning, online machine learning. The first set of online machine learning that we have the scikit multiflow, which at times is called SK multiflow. We also have the Ubatus. This one is an open source online machine learning, and it is a distributed computing system. We have the Kremlin framework. The Kremlin framework also is a Python library. We can make use of it. But with the advent of River, which combines both the scikit multiflow and the Kremlin, you don't need the two again. So you just stick to the River to make use of your online machine learning. So let's just quickly talk about the River Python library. The River is a Python package for online or streaming machine learning. River is a library for incremental learning. Incremental learning is a machine learning regime where the observations are made available one by one. As we said, the process of streamlining and analyzing it is bit by bit, not the regular putting everything together and you have to analyze. No, it is a bit by bit, one after the other. So you must take decision immediately you analyze it. As I said, the River is the combination of primary and circuit multiflow. River can perform learning tasks like classification, regression, clustering, and concept drift detection. Now, when we say concept drift detection, we mean noise can creep into your analysis and that can distort the modeling and you have to quickly analyze immediately you have something like that. Like if you have an event of let's say stock market that is going off, going off and you have to sell immediately, that aspect is like your concept drift. You must detect the event immediately. Let's also look at the issue of the load shedding we experience during the winter period. It is an event that comes in and you don't know how to quickly analyze it. But when it comes, you must be able to take proactive decision about it immediately. Quickly, let me go to some of the models that you can use in for River Library. For that, you have two main functions: you learn and you predict. you learn, then you predict. Those are the two main core functions that you do with River. For the learning task, you either learn one, use the learn one, that's one function, or to do another one, which is predict. You learn one, you predict one. For the predict, you have the classification, regression, and clustering. Those one is for the predict. Then for the predict probability one is only for the classification modeling. And you can also do core one or anomaly detection. That is when you have noise creeping in into an event. An event is called an anomaly if it is different from other set of events that is taking place. Take for instance fraud that comes in say, let's say in insurance procurement, or want to say something like you want to look at people making unrealistic promises of an event. Anomaly can take in and can easily detect those things. So River contains transformers, and I hope we know of recent that issues of transformers has been discussed mainly in machine learning of recent. And one of those transformers that you can use is the transform one method. A simple machine learning code using River. In simple machine learning code, as I said, there are two events that you can do. You can learn and you predict. Then you can measure the accuracy of the events that you are predicting. So in Rivers, well, we are all known. Guru in Python. You know that if you want to use a library, you have to import it. You have to first download it by using the pip install, the name of the library you want to do. So I assume that you have been able to have River library in our platform. The first thing is for you to import it, then import those things you want to use. You want to evaluate the result. You want to perform some metrics there. You want to use some algorithm. For these three, it is machine learning algorithm. Then you want to play around with data sets. Like in River, in Rivers, in machine learning streaming data, there are two types of data sets you can use. One of them is the synthetic data, and the other one is the real data set. In case you don't have access to real data set, then you can play around with your synthetic data set. That is, you formulate, you try to repeat what the data set is trying to do. So for you to get the synthetic data set, you will first import your data set, then you will see that this value you is synced, then you can use either a random RBF generator, or you can use the waveform, generate your synthetic data set. For this model, I'm talking about simple classification. So, and after doing the analysis, the accuracy there gives us for that value 97.28%. So River also contains pipelines. You can put in more than two lines of code, and you want to use pipeline to show what events you are trying to do. Let us see pipeline. Pipeline are integrated part of River. They are a convenient and elegant way to chain a sequence of operations and warrant reproducibility. The pipeline is essentially a list of estimators that are applied in sequence. So how do you have your pipeline? In River, you have to import a linear model, then pre-processing. Then you can model this, you can put these two together under model to view it, and it will tell you what you are doing. You can see for the pre-processing, you have the standard scalar, and for the linear model, we are talking about the logistic regression. And if you want to show the pipeline tells us that the first thing we are doing there, we are looking at the standard scalar, then followed by the logistic regression. It will give you the series of events you are performing. So, clustering using River, because one of those areas in data stream is the clustering. And in clustering, data stream clustering, you have some algorithms like clustering. These are some of the algorithms that you have in River. In massive um, analysis, online analysis, there are more. But in Rivers, we just have only 6 of them being implemented as at now. We have the cross stream, we have the DB stream, then we have the death stream. This DB stream and death stream, they are part of the density-based algorithm. Then we have the k-means, we have the stream k-means, and we have the test clustering. So we want to look at just 2 of them, which is mostly defined in massive online analysis. The first one is the clustering, and the second one is the death stream. I will talk about the 2 of them. The 2 of them have 2 ways of processing them. We have the online phase and the offline phase. So the algorithm is like this. The data stream comes in, it is analyzed using the microcluster, and for you to predict it or to give the validation, you can do that offline. There are some that everything you do will be online. It will be online. But the time will not permit me to go into those things, those areas, those algorithms that focus on online. But we are only talking about River. I didn't think we are talking about the massive online analysis. I would have given you examples of those ones. So let us look at the clustering and the algorithm. The clustering algorithm was first done by Agarwal in 2003 under this framework, under this how can I put under this dissertation thesis, a framework for clustering involving data streams. I find the book, the journal, and read more about it. So, as I said, it has both online phase and the offline phase. It is a partitioning-based clustering algorithm and has a spherical shaped clusters. However, it cannot detect arbitrary shaped clusters, and it is sensitive to outliers. So how do you analyze clustering using River? In clustering using River, let us just play around with this example. We have an array, 2-dimensional array data set I want to look at. First, you import the cluster, and under cluster, you have the clustering. On that cluster, you have the clustering algorithm there. So you set the parameters. These are the parameters for clustering, the inbuilt parameters, the default parameters. You can play around with it at times so that you get an accurate analysis. So the first thing you do, as I said, you learn one and you predict one. So you don't learn multiple events. You learn one, then you predict one. So after the learning phase, you can now say, okay, let's say for the first array, can I have one? For the second set of array, can I have one? How many of them can I have under this data set? The result shows us just one. And if you want to predict more, let's say I have minus for the first one, minus one, and three. How many of this event can I have? The analysis is said two. And if you play around, the analysis says zero there if you have 4 or and 3.5. So let us look at three data sets. We want to look at three data sets. In this three data set, we are using the chameleon data set, one of the chameleon data sets. I would have been able to show us what this data set looks like, but it's one of the very useful data sets in machine learning. So if you read through the data set, this is the data set, the output. So we want to predict it. For us to predict it, we have to import our NumPy so that we can read the data in array. So after reading the data in array, we learn one, and we can play around with that data set. We want to see if in the first column here, we want to have 50, and second column, we want to have 200. I want to predict. It says only one of these will be possible. So let us look at dense string. In dense string, we have a lot of varieties, but I will not be able to go through it. But the major one was first written by Howe in 2006. You can find the literature if you are interested. It is well used. Dense string is a density-based algorithm with the ability to discover arbitrary shaped clusters in evolving data streams. It can handle outliers, but risky when there is noise. Dense string has three microclusters, which are core microcluster, potential core microcluster, and outlier microcluster. The core microcluster here at times moves to the potential microcluster. And when there is an outlier in the potential microcluster, it will degrade and you have an outlier microcluster. So let us see how that works with River. I'm sorry about that. In River, you also import the cluster, then you also import the stream. As I said, we want to play around with the data set. We are just using fictitious values here. And the default setting, one, you have the decaying factor, you have the beta. We'll talk about the beta, the epsilon. These two ones, they are the most user define specifications at parameters. Epsilon, you play around with your epsilon and mu mostly. So you can vary the scores And let us see if we want to predict if there is -1 and -2 in our result, says there is 0 of them. So since it has been able to read these values, I want to see, let us see if we play around, can I have 5 and 4? Ability. What about if I have 1 and 1 have the same chameleon data set? We want to play around with it. You know, we did the same thing in when we are trying to use the plus string. Then we want to use this dense string. So the same process, but a few differences there. Now we want to calculate if we have a 150 in the first column and 200 in the second column. So there is 6 possibility there. So you can try to check this and read more about how to use data stream, reverse for data stream.
Sorry.
So thank you for
Oh,
attention. So I want to round up. Thank you for your attention. So, this is my email address, and you can check me on the LinkedIn to see my profile. Thank you so much. I would like to take a question if there is any.
thank you so much, Tajudeen. A round of applause for our speaker. Any questions?
I just wanted to quickly check something. With River, can you combine it with models that are outside, that kind like third-party models, to train your data?
Yes. You can combine it with a scikit-learn model from scikit-learn. You can put it in, incorporate it there. If you want to use it, you work with everything. You can bring in some other libraries from Python and to use with it. I hope I answered your question.
Okay, thank you. Any other question? Okay, I have a question. There was a slide that you showed where you were showing the data stream conversion to a heat map. I wanted to know what kind of data stream requires like clustering. An example of a data stream that would require it to be clustered.
Okay, data streams that can have a clustering, like you know the difference between classification and clustering. For classification, it has been prescribed that this is the actual value, the output for it. Like if it is you want to flag if it is a yes or a no for somebody to be promoted by this using academic record. If they have this, then you use classification. But when it is not divine, you don't have any way to say this is the real thing you have there, the classification. You don't have the way to classify that data set, and you use clustering. But for data stream, as I said, it is different from the traditional way of clustering. It comes regularly, frequently, and you have to analyze it as it comes in. And you cannot use most of the available data, tools for it. You have to use special tools like the river. In R, you use stream or stream stream Moha in R. In normal data set, Java, JavaScript, Java, Moha is written for it. That is the massive online analysis. That is the major one you can use for it, for data stream analysis. The major one. As there are a lot of specifications, but the one that is most effective is the massive online analysis. And a lot of communities development is taking place. Part of those people that wrote her, they are also working with the community in Moha. I hope that is clear.
Yeah, thank you so much. And thank you so much for introducing us to data stream with River. And
thank you so much. I really appreciate it.
Okay, great. Another round of applause.
Thank you.
Oh, Tajudeen, there's another question for you.
All right, no problem. Yeah.
Yeah, so what I wanted to check is, since this thing is running on streaming data, so it's training and predicting frequently.
Yes.
How do you stop it from overfitting?
No, there's no issue of overfitting with the data stream, because it is coming bit by bit. There's no issue of overfitting here. You have to predict it as it comes in. It may just be like your time series. You know, time series, it is an event. It comes regularly with an event. But in this data stream, you must predict as it comes in. I hope that is clear. Because I said issues like the concept drift can come in, and you may not be able to notice the concept drifts that comes in immediately. You have to just use my tools to analyze it immediately. That's why we have special tools for it.
Thank you, Tajudeen. Our next session is going to start at past, so we have like 10 minutes before the next session.
I can stop sharing my screen. Thank you so much.